All right, hello and welcome. In this video, we will be going over solving equations with variables on both sides. So if we have a variable and we're trying to solve for it, but it's on both sides, right, this might seem like a tricky task. It might seem challenging for us to solve. However, we are just going to continue to use those inverse operations to solve here. So in this example problem, we have 4x plus 6 is equal to 6x minus 8. So I see, okay, I have x's on both sides. I don't want x's on both sides. So what we're going to do is eliminate the variable from one of the sides. So in order to do that, we can subtract either 6x from both sides, right? If I do that, boom, 6x minus 6x is just 0, so that'll cancel out. Or you can subtract 4x from each side. So if I subtract 4x from the left and right, I will cancel the variable on the left side. It's really up to you. I prefer to subtract whichever one is smaller, but it really doesn't matter. Either way, you're going to get the same answer. It just might mean that you're dealing with negatives along the way. So let's subtract 4x from each side, and that is going to eliminate the 4x on the left side of the equation for me. So now I'm down to 6 equals, well, 6x minus 4x gives me 2x minus 8, and now I have just a two-step equation to solve here. Remember, I'm using the reverse of the order of operations, so reverse of PEMDAS. Right? What's the last thing that would happen to my variable x here? Well, it would be multiplied by 2, then 8 is subtracted from it. So I'm going to add 8 to both sides. Add 8, add 8. That cancels on the right. I get 14 is equal to 2x, and that's a 2 times x, so just divide 2. Divide 2, that cancels, and I get x is equal to 7. Okay, I finish with x is equal to 7. Let's just try this out. Let's do 4 times 7 plus 6. Is that equal to 6 times 7 minus 8? Let's see, 4 times 7 is 28 plus 6. This is 42 minus 8. 28 plus 6 is 34. 42 minus 8 is 34. So we know we did it right. X is equal to 7. Beautiful. All right, let's move on to another example that looks more challenging. However, the same exact steps here. So now we just have a couple of times where we need to distribute. So I'm just going to start by distributing and then combining like terms on each side. So I distribute this 3, I'll get 6 minus 12b plus 2b equals, and let's distribute on the right side. Negative 2 times 3b is a negative 6b, and negative 2, that didn't finish. Negative 2 times a positive 5 gives me minus 10. All right, let's combine like terms. So I have a negative 12b plus 2b, which is a negative 10b, and that's equal to negative 6b minus 10. All right, let's get all of the b's on the same side. So I'm going to add 10b to both sides. You could have added 6b to both sides as well. Okay, it's really up to you, whichever one you prefer. We're just trying to eliminate it from one side. I chose to eliminate it from the left. So that cancels. I'm left with 6 equals 4b minus 10. And now we solve. So b times 4, then subtracting 10. So I do the inverse operations in reverse order. So I start by adding 10 to each side. Add 10, add 10. I get 16 equals 4b. And now I'll divide both sides by 4. Divide by 4. And I wind up with b is equal to 4. All right, you could check your answer up above, but I promise you that will work out. So with these problems, we're just going to simplify each side as much as we can by distributing, combining like terms, then get those variables over to the same side and solve, right? Clear that variable from one of the side and just finish solving. Nicely done. Have a good one.